Okay, now this neutral axis is going like this, separates the tension zone from the compression zone. Like I said, this place will now go, this section will go into tension because the internal element of this section will start to undergo tension, so that due to the bending, here we start to stretch like this, here we stretch like this. The point will come, they will put this particular um, uh, they will put it in tension. They start to stretch it. But at this other side, they start to squeeze due to the bending. You start squeezing. So here we have your tension, and while up here you have something like this. You're just trying to squeeze this particular side. Here we have what we call compression. Now, when this thing is happening, concrete goes into work, start resisting the compressive stresses and forces on the compression zone. While on the tension zone, concrete does not have all the strength and ability to start resisting. That's why we now reinforce. Now, by the time you now put your steel, by the time you now put your steel in the tension zone, the steel will now go into action, resisting those tensile forces, and that's what we are looking at today. Now look at what happens during that bending. There will be an equilibrium. During that very bending, the effect of the bending will give rise to resultant force in the compression zone, and also to a resultant force in the tension zone. So that at equilibrium, it must be at the equilibrium, that the moment of the design moment and the ultimate moment of resistance must be equal at equilibrium. And I have my end moment will be equal to the force acting on the steel section, on the compression section, which is the FCC, multiply by your lever arm C, and is also equal to the FST, force on the tension zone, multiply by that same lever arm Z. Look at the lever arm here. This force times perpendicular distance. This is your lever arm. That's that distance Z. The same thing for this other one. The FST will equally go that distance. So we have this. Now considering the moment in considering the compression zone, at my M is equal to the FCC multiplied by Z. Let me just denote this one as my equation one. Equation one. Now, what happens? What is force? Force is a stress multiplied by area. So the stress in the stress section, the stress of the concrete here is 0.567 FCK. So I have my M will give me 0.567 FCK multiplied by the area of this section, which is BS, multiplied by Z. I will call this one equation 2 for clarity. For clarity. Now, I can break this in further. I know that from what I have here, that my Z is D minus X over 2. That my Z is the effective depth subtracted by X over 2. So from here, I can make my X the subject. From here, I can have that my becomes becomes equal to 2D minus Z. If you do it very, very well. Because by the time you apply, strike out this, we go into this. Have this. So I now say substitute X, substitute for X into equation. Use this equation 2. And I have that my M is equal to 0.567 FCK. FCKB, then 2 into 2 into D minus Z. multiply by z. So by the time you strike out, I have 1.134 FCK B into yes, okay, into dz minus z squared. So by this, let me clean it. I'm now solving. I'm now solving. I'm now solving. I need to solve this very well. I need to solve this very well. I have that my n is equal to 1.13 for FCK B into dc minus z squared. So if I should divide through by 1. If I should divide 2 by FCK, I have that n over FCK B equals to 1.134 into dc minus z squared. I can equally further divide both sides, divide all through by d squared. I can divide all through by d squared. Divide through by d squared. I'm just trying to explain the whole thing in a more clear means so that anybody can understand how the derivation came to be. So now let me simplify further. Let me simplify further. Let me simplify further. So I have n over FCKBD squared is equal to 1.134 into half c, c over t minus z over t squared. So at this point now, I can now assign the whole of m over FCKBD squared to a particular constant. I will say let my k equal m over FCKBD squared. This assigning helps us to solve problems, to make solving complex problems very simple. Now all the thing we have here is now equal to k. K equal to 1.134 into z over t minus z over t squared. So divide through by 1.13, half k over 1.134 is equal to c over t minus z over t squared. So this is looking somehow, it's looking like the normal usual quadratic equation. So I will simplify more. Simplifying more, I have z over d all squared minus z over d plus k over 1.134 is equal to 0. Something like this is now a quadratic expression. So I can now use the almighty formula or the general formula of solving my quadratic equation to simplify. Because I know something, I know that in simplifying a quadratic expression using the general formula, I think I have ax squared plus bx plus c is equal to 0. That here x becomes equal to minus b plus or minus root b squared times 4ac all over 2a. So if I should compare with this equation, comparing, making the coefficients look equal or look same from this general formula, I should have that my z over d is equal to 0.5 plus root 0.25 minus k over 1.134, such that my z becomes equal to 0.5 plus root 0.5 plus root 0.25 minus k over 1.134 bracket d, like this. So with this now, let me write this down somewhere. So with what I have here, I'll be wiping, because this board is very small. I'll be wiping. So therefore, I have that this is the one equation we try that z is equal to 0.5 plus root 0.25 minus k over 1.134. So with this now, we are able to establish this constant. The value of z is this, telling me that La is equal to 0.5 plus root 0.25 minus k 1.134. That is okay. And that's for this. Now let's now also look at the force, from the still zone or the tension zone. So the moment from the still zone or from the tension zone, so look at it from the tension zone, which is this. That same moment is equal to FST, force in the tension zone multiplying by your Z. Now, this force is stress multiplied by your area. Stress multiplied by your area. You already have your area of ST here. So FST is equal to FYK over partial factor of safety. Partial factor of safety multiplied by your AS. Now, this FYK, I will explain. FYK is the characteristic strength of steel. FYK means characteristic strength of steel. Why this gamma S is what is the partial factor of safety, and is given as 1.15. Partial factor of safety is given as 1.15. So by the time we now bring it here, by the time I bring it here, how my FST becomes equal to FYK to 1.15 divided by AS, and this will give me 0.87 FYKAS. So therefore, moment is equal to 0.87 FYKAS multiplied by Z divided by. So therefore, from this expression, M is equal to 0.87 FYKZ. So the area of steel I'll be looking at and looking for will always M over 0.87 FYKZ. So this is another parameter. It is very important. So for a singularly reinforced section, concrete section, if I'm looking for the area of the concrete to provide, the area of the steel to provide, with this formula here, I already know my Z, the lever arm. Now the FYK is the catalytic strength of the steel. Some places they use like here we use 4 410 Newton per mm squared. That's what we use here. Some places they use 500 Newton, but normally FYK we use 410 Newton per mm squared. Some place we use some place we use 500 Newton per mm squared. So depending on the strength of the steel, normally the steel is meant to go for the tensile test, tensile strength test. That's where they take the steel, one obtainable in the market in your own location, your own locality. That's where they take the strength, the catalytic strength of the steel. So now with this now, this is your moment that you are going to compute doing your design, doing your structural analysis. You compute a moment. That moment is like the applying moment which you computed. You now put it inside here. It will now guide you to know the area of steel that you provide. Mind you, for a singly reinforced section, for a singly reinforced section, the value of x and z is always limited. Is always limited. Yeah, it's always limited. The x is always limited to as 0.45 d. That's the maximum depth of the neutral axis it can go is 0.45 d for a singly reinforced toe. So it must be limited. So anything above this, that means you're now going for a W reinforced. That is a situation whereby you reinforce at the compression and equally reinforce at the tension. That's the next one we're still going to derive. Understand? Now also the limiting the z value is always minimum. It's always minimum. So the least value of the z that you can use for a single reinforce that is obtainable for a single reinforce is always 0.887 d. 0.87 d, the value of the lever arm that you can be able to use. So from this equation, from that equation 3 which we got that time, that 1.13 for FCKB into d minus z and z. From this equation, if you now put the limiting value, that's the minimum value of z inside this equation, compute, you now get the moment. That's the moment that the maximum moment that you have to use to compare, because during your calculation, the apply moment and the moment of resistance must be equal for it to apply and to provide only reinforcement in the tension zone. So a point whereby the apply moment is greater than the ultimate moment of resistance. In that way, there will now be a need to provide to provide reinforcement at the compression. So by the time you solve this, we have 1.134 FCKB into d minus 0.87 d into 0.87 d. By the time you strike the bracket off, you have 0.165 FCKB d squared. So this now must be equal. The moment of the apply moment must be equal to the ultimate moment of resistance, which is equal to 0.165 FCK BD squared. So anytime this apply moment is greater than the ultimate moment of resistance U, there is need provide you now provide for reinforcement at the compression zone. So these things happens. This things happen. So any time the apply moment is greater than the ultimate moment of resistance. That means you have to provide reinforcement at the compression zone. That's that time now you now come and start providing reinforcement here being the compression zone. So that will happen. That will happen. So that's the next we're going to look at. But for now, all these formulas, master them, write them down somewhere. We're gonna be making use of it. Thank you. Please like the channel, hit the like button, subscribe, hit the notification button so that I can be able to receive notification when I post my videos. We post videos 2 times in a week. Thank you.